This conference will now be recorded.
Okay, so we're looking at the OSI and the TCPIP model. So if you remember, we're setting out foundations of networking. So the objective of this mentoring program is to arm you with the necessary skills, knowledge, understanding to fit into the role of a network administrator or a system administrator. So it's more of an introduction, more of setting out, giving you an understanding of the basics. Now, when you talk about networking, network administration, or networking in general, there are concepts that are very, very key, and one of them is the OSI TCPIP model. So we'll be looking at this part A of this module 2, which is OSI TCPIP model. Okay, so I'll just give a bit of background understanding to the OSI TCPIP model. Now, at the formative stage of the internet networking, many people were building appliances independently. They were building maybe a computer independently around the world. So, but they couldn't communicate with each other because they were not conforming to a standard. So just like a language is, if I learn French in Nigeria here or in any part of the world, I can go to France, I can go to any part of the world and speak French. So anybody who understands French will understand what I'm saying because I have conformed to a standard, I have conformed to a language. So whenever I speak that language, everybody who understands that language will speak. So in networking, they came with a model, a standard, a reference model that every network equipment manufacturer will build their devices to conform to it. So if I am building a smartphone and I want it to be able to connect to a Wi-Fi, there is a model I will have to build my Wi-Fi adapter to conform to. If I'm building a laptop and I want it to connect to a network or maybe connect to Bluetooth, connect to Wi-Fi, connect to a cable, there are standards that I must conform to so that my Dell laptop can connect to a Samsung laptop, a Samsung phone. My Samsung phone can connect to a HP laptop. So this model was what brought about that uniformity where you can have different devices as long as they conform to that model, they'll be able to interpret with each other. So one of that model that is very, very key in networking is what we call the OSI reference model, which means the Open Systems Interconnect Reference Model. Now, this one interesting thing with this model is that it constitutes of 7 layers. 7 layers. What it means is that if I am building any network equipment that should be able to integrate with another network equipment, it must conform with these 7 layers. Okay, so it must conform with these 7 layers, and it starts with layer 1, which is the physical layer. It starts from the bottom up. Layer 2, which is the data link layer. Layer 2, which is the network layer. Layer 4, which is the transport layer. Layer 5, the session layer. Layer 6, the presentation layer. Layer 7, the application layer. So all of these layers are a reference layer that every network device must conform to. And one of the easy way to remember this is all people seem to need data processing. All for application, people for presentation, SIM for session, to transport, need network, data for data link, processing. So you must be able to understand this layer because it is fundamental to networking. If you want to understand networking, the first question you will usually be thrown at is, what is the OSI model? What are the 7 layers of the OSI model? No matter how, these are like the ABCs of networking. No matter how advanced you are in this area or subject area, you must still have to come back to the OSI reference model. So all people seems to need data processing. The all is for layer 7, which is the application. The people is for presentation layer. The SIMD is for session layer, 2 is for transport layer, NID is for network layer, layer 3, data link layer, then physical for physical layer. So it's a very, very interesting model. Now, I would try and explain what each of these models does so that I won't have to go through many slides. Now, the application layer is what you interact with. So something like your web browser, it fits into your application layer. So if you say you want to go to Google, you want to browse a website, you open up a web browser. That is what you interact with. So your application falls in the application layer. So your web browser falls in the application layer. Your download manager, your internet download manager, anything you use to download on the internet falls on the application layer. Your Outlook client, whatever it is you use to send your mail or receive mail, falls on the application layer. That application that allows you to interact with the network, that allows you to communicate over the network, is called the application, is under the application layer. So all the software development, all the software engineering they do, all falls at the application layer, whether it's a mobile application, a web application, a desktop application, it is at the application layer. Now, you now have what we call the presentation layer. Now, these applications, they generate data, they generate information. So, for instance, if you are browsing a web page, it will convert whatever it is you do into HTML. Now, HTML is what we refer at the presentation layer. It is presenting it in a format that can be transported or can be transported through the network. That is at the presentation layer. If it is a file, you have it in PDF. PDF is the format of that information. If it is music or if it is a song, it is in MP3 format. MP3 is at the presentation layer. If it is a video, it might be MP4. It is at the presentation layer. So whether it's a Word document you are sending, it is maybe doc document or TXT file. At that layer, it conforms to the presentation layer. There are also more advanced codings like the ASCII, some of these computer science terms that also comes in the presentation layer. But in a much more simple sense, it is more like the form which your data is being formatted, whether it's a PDF, whether it's an HTML, whether it's a text, whatever it is, that format falls at the presentation layer. So that's at layer 6. Then going down to layer 5. Now, you agree with me that if you open a web browser and you are browsing the internet, you can be on a tab. Maybe you are browsing CNN.com. You open another tab, you are going to YouTube. Another tab, you open your Gmail. You are able to logically open different tabs. Some people could have 10 tabs on their web browser when they browse. Now, how does your system logically separate them? That when you are going to YouTube and you want to watch a video, it will not show up in your Gmail. So that is what session layer does. It logically separates your activities in sessions. So it's able to separate your download from your video streaming. It's able to separate your Netflix from your email. So it's able to logically separate them. So all the interactions you are having on the network is logically separated into sessions. That is what happens at the session layer. So it is separated in sessions. Now that is at the session layer. Now at the transport layer, the data here is now broken into what we call segments. So from application, presentation, and session layer, it is still called data. Now when it comes to transport layer, it is called segment. And why is it called segment? Because it is actually broken into chunks. From the word segment, to segment means to break something into chunks. So that data is called segments in transport layer because it is broken into chunks. For instance, if you want to eat, maybe in Nigerian culture, you want to eat gari eba. You can't just swallow everything. You need to break into small chunks before you can digest, before your belly or your tummy can able to digest that food. You need to take them in small chunks. You can't take everything at once. You need to take them. That's why we have spoons. We have so that you can take that food in small chunks, in chunks that you can process, in chunks that you can digest. So transport layer is where you break down that your big data, or that data of yours, into small segments that are able to transport over the medium, whether it's a wireless medium, a wired medium. Now, that's one of the key things you need to understand about the transport layer. Another thing also you need to understand at the transport layer is also that it determines the types of transport it will transport that data. For instance, there's what we call connection oriented and connection less oriented. For instance, when you send a message, some people will want to get a feedback before they continue. Just the way you send a message, you say hello, you want a hi before you continue that message. That is a connection oriented communication. You're expecting a feedback before you continue. That is one. Another example of a connectionless oriented is when you are sending a message, like a radio message. When they broadcast a radio message, they are not expecting your feedback. They continue to stream or continue to broadcast whatever it is that they are broadcasting, believing that you are getting what they are saying. So they are not expecting you to give them a feedback before they continue with their broadcast or continue with the message. So that is an example of a connectionless oriented transport or connection oriented message. Now, how does it signify in networking? Now, when you want to go on YouTube, most like video streaming and audio streaming are called connectionless oriented communication. The reason why is that when you are streaming a video, you are not waiting for feedback. They are streaming it live. So whether you have network issues or your network is having that is buffering, they are streaming live. They are not waiting for your feedback before they continue with the streaming. That is an example of a connectionless oriented communication. Now, a connection oriented, that is connectionless. A connection oriented means that you will wait for a feedback, just like a web page. It will tell you when you are trying to go to that web page, it will load and tell you that page not found. It's giving you a feedback. It might tell you page redirected, but it always gives you a feedback that this page that you are requesting for, maybe it is not found, maybe it is available, maybe it has been changed, but you always get a feedback. That is what we call connection oriented. And at the transport layer, there are some protocols that are responsible for whether it is connection oriented or connectionless oriented. The connection oriented is the TCP, called the Transport Control Protocol. Transport Control Protocol. The connection less oriented is handled by a protocol called UDP, User Datagram Protocol. User Datagram Protocol. So whenever I want to send a message that is meant to be connection oriented, I will use TCP. TCP will be my messenger. TCP will be my messenger because it will give me a feedback. If I want to send a message and because of the sensitivity or because of the form of message I want to send, I am not waiting for a feedback, then I will use the messenger UDP. So UDP will be the protocol that will send my message and I won't be expecting a feedback. So that is layer 4, the transport layer. These things are very, very simple, very, very simple. Then the third layer is the network layer. The network layer. I remember I said at layer 7, layer 6, and layer 5, application, presentation, and session layer is called data. At layer 4, it is called the information at that layer is called segment because of segmentation. Now, at layer 3, before it gives it to layer 3, what it does, it attaches some information to that data. So you have what we call a source port number and a destination port number. So an example is your letter. Whenever you want to send a letter or even an email address, you will have a source email and a destination email. You have a source address and a destination address. When you want to write a letter, you will have an addresser and an addressee. So the addresser will attach his information that I am sending this message from so location, and this message is to be delivered at so location. So that also plays here, where you will have a source port number and a destination port number. So the source port number tells you that, okay, from where I'm coming from, this is the port I am coming out from. Then I am sending it to this destination port. So at the transport layer, data is added. At the transport layer, some information are added, the source port number, the destination port number. Now, when it gets to the network layer, we call it packet. Some of you have heard packet before. Packet. The word packet is information at the network layer. It is called packet. Remember, information at transport layer is called segment. Information at network layer is called packet. Now, at the network layer is where you have IP addressing, what you call internet protocol addressing. IP means internet protocol. IP, internet protocol. So IP addressing. So at the IP addressing, from the word address, you will have a source IP address and a destination IP address. A source IP address is your address. A destination address is the destination's address. So every device in the network, before you can connect with each other, you must have an address. For instance, before you can push a call to somebody, maybe a GSM call, you must have the phone number of the person you want to call. That is the destination address. And you must have a phone number before you can call someone. That is your source address. So for you, you'll be dialing a destination address. For the receiver, you'll be getting a source address that this is the person calling me, and he's calling me from MTN, he's calling me from Glo or from Airtel. So that is how it works here. So there's a source IP address, there's a destination IP address. So whenever you are sending information anywhere around the world, you must have an IP address, and wherever it is that you are sending that information to must have a destination IP address. I hope that's clear. So that's the network layer, and the data at that layer is called packets. Now at that layer, it will attach the source IP address and the destination IP address. At the transport layer, it attaches port number, source port number, destination port number. Network layer, source address, destination IP address. Now that information is called the network packet. Now after it has done this, it takes it down to the data link layer. Now the data link layer, the information at the data link layer is called frames. So at down this thing, it is called frames. Remember, transport layer, it is called segment. Network layer is called packet. Data link layer is called frames. Now, in frames is what we call MAC. That's where we have MAC addresses, media access control addresses. MAC means media access control. At the data link layer, we have MAC address, media access control address. Now, the MAC addresses are what we call physical addresses. There is what we call burnt-in addresses. Means those addresses are like your fingerprint, that it remains with you. So whatever, any device in the world that communicates on the network has a MAC address. Whichever device, whether it's a phone, whether it's a smart TV, whether it's a laptop, a desktop, whatever device that connects on the network, it must have a MAC address. And those MAC addresses are burnt in, meaning that it is coded to that hardware. You cannot change it normally unless you use a software to change it, but there's always a manufacturer's address that is tied to that appliance, to that device. So, and that is what we call the MAC address. Now, information at that data link layer is called frames. So at that layer, you have a source MAC address and a destination MAC address. A source MAC address and a destination MAC address. Then when it has passed layer 2, it goes to layer 1. Layer 1 is where it is broken down into bits, ones and zeros. For some of you who must have done computer science before or done physics a bit, You must have heard of zeros and one, binary, zeros and one, and it must have told you that information is being sent or received in bits, zeros and one, on and off. Some of you must have done engineering or electrical, you will understand this better. So at the physical layer, the information is being broken and translated into digital signals where you have zeros and ones, and it is being transported. So at this layer, it is called bits. The information at this layer is called bits at the physical layer. So at this physical layer is when it is now going to be sent through the cable or through the Wi-Fi or through the microwave, whatever form of medium that you have, falls at the physical layer. So I've explained the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. I will try and piece everything together by giving a scenario of you visiting a website, how each and every of these play in. So just going through the slides, application, you have file, print, database, application services, you have data encryption, compression, translation, format. We also have at the presentation layer. At the session layer, you have dialogue control, where you will separate them into sessions. Transport layer is where you have end-to-end connection. Network layer is where you have routing. We'll look at routing, be able to explain what routing is. The data link layer is where we have the framing. The physical layer is the physical topology, the physical appliances or mediums. So as I explained earlier, application layer provides the user interface. Presentation layer presents the data in a format. It handles processing such as encryption. Session layer keeps the application's data separate. Then at the transport layer, it provides reliable, connection-oriented, unreliable, connectionless oriented delivery. It also performs error correction before we transmit. The network layer provides logical addressing, which router uses for path determination. The data link layer combines data into bytes and bytes into frames and perform access to media using MAC address, as I've explained. Then the physical layer moves bits between devices. That's where you have voltage, wire speed, pin out of cables. So I've explained the application layer. So you have application, file transfer, your email, remote access, client server processes, the presentation layer, as I've explained here, your session layer. I've also explained what session layer that is able to keep sessions separate, is able to manage these sessions separate. Then the transport layer is what does the end-to-end. So I've explained the TCP and the UDP. The TCP is connection oriented. The UDP is connectionless oriented. And the data at this layer is called the segment. Network layer, said the data at this layer is called packet, and it also helps in the transport of information. So the network layer is at layer 3. The data link layer is at layer 2. I've explained the hardware addresses, the MAC addresses, and data at this layer is called frames. And I've also explained the physical layer, which is in bits. Data is called bits here, and it is all zeros and ones. Yes. So that is the OSI reference model. That is the OSI reference model. So let me go back and give a bit of context to this. So we'll go to the TCP/IP model. But let me give a bit of context to this. So I want to explain using this model what happens when you go to your web browser and you type www.google.com. When you go to your web browser, you type cnn.com or you go to any website, what happens at the background? So it's what I want to explain. And this also plays out for whether you are doing a web, whatever form of application that you are using on your system to interact with the internet or interact with the network, it also plays the same. So I'm using the context of somebody wanting to go to Google, www.google.com. Now, at the application there is where you have your web browser. you type in www.google.com. Now it makes a request for an HTML. So for some of you who must have done a bit of web or understand a little bit of web, you must have heard of HTML, Hypertext Markup Language. That is the format that web pages are made in or presented in, HTML. So when you want to go to google.com, it will request for an HTML page, which at a much more advanced sense for web developers, they will say it's making a GET request. So it's making a web request. So you are requesting for a web page. Now that HTML, it is being formatted in HTML at the presentation layer. So in a format that it understands, that your web browser understands. Now at the session layer, is able to create it in a separate session. So you have a tab for it, separate. That is what happens at the session layer. Now at the transport layer, because a web traffic is a connection-oriented traffic, meaning it uses TCP. Some of you must have heard of TCP port 80, TCP port 443. We will see some of these ports even as we go further, but I just want to give context to the OSI reference model. So so at the transport layer is where you have ports. So for instance, I will have a locally generated with my source port address. Okay, so I have a locally generated port as my source port address, and I have a destination port, which will be port 80 or port 443. Port 80 is used for HTTP. HTTP is a clear text protocol, while port 443 is used for HTTPS. For some of you, you go to a website, you will see a symbol like a padlock. If you check it, it's using HTTPS. So HTTPS is on port 443, HTTP is on port 80. So at that transport layer, it embeds on that data, that HTML request port. The source port is a locally generated port, which is random, and a destination port, which is port 80 for google.com. Now it now gets to the network address at network layer. At the network layer, it attaches your IP address, the IP address of your system. It attaches it to it. Then the IP address of google.com. As we go forward, we'll be talking about what we call DNS, and DNS is what maps URL to IP addresses. URL is www.google.com, www.cnn.com, www. Any website that you type those URL. That's what we call URL, that name. You don't type the IP address. It's just like in your phone. You don't have everybody's phone number in your head. You only have their name. So your phone directory works like a DNS record where you have names mapped to phone numbers. So in networking, we have such kind of record called DNS that maps URL to IP addresses. So your system gets the actual IP address of google.com, then it attaches it to the message or to the packet at the network layer. Then at the data link layer, your system will attach its MAC address and attach the MAC address of the next device. So maybe it's your switch, maybe it's your router, it will attach that MAC address. Then at the physical layer is where it will convert that your information into bits of zeros and ones, then send it through the medium. So whether it is Wi-Fi, whether it is LAN, it will send it through the medium to Australia, to wherever Google hosted their service. Then from there, it will get to Google server as bits of zeros and ones. Google will convert it into data that it understands at the data link layer. It will strip the MAC addresses. It will strip the IP addresses. When it checks the IP address, it will check the destination. Is it meant for me? If it says yes, this is my destination, this is my IP address, it will strip it. It will check the port. Okay, port 80. Do I have port 80 open? It will say yes. It will now check the session presentation application, then get that Google web page that is hosted on Google's web server and send it down through the same way downwards to you in Nigeria, to you in Lagos, for you to get that web page. So when you type www.google.com and it loads up in nanoseconds, this is what happens on the back end. Very, very fast at the speed of light. This is what happens on the back end, that you're able to get that page running on your web browser. So that is a practical application or practical reference to how the OSI model works. Okay, so the TCP/IP model. So the TCP/IP model is also quite similar to the OSI model. It's very, very similar to the OSI model. In the sense that the TCP/IP model was first of all what was made in vogue. It is also called the DoD model, Department of Defense model. Now, the TCP/IP model constitutes of four models. It constitutes of four layers. You have the process or the application layer, the host-to-host layer or transport layer, the internet layer, and the network access layer. So this is how it is. It has a process layer, which is application, the host-to-host layer, the internet layer, and the network access layer. So it has four layers as compared to the 7 layers of the OSI model. Now, what if you can see this diagram very well, you can see the comparison, the similarities and differences between the two of them. So the first layer of the OSI or DoD model, Department of Defense model, is the same as the first 3 layers of the OSI model. The host-to-host layer is the same as the transport layer. The internet layer is the same as the network layer. The network access layer is the same as the data link and physical layer. That is just it. So when you are asked anywhere, what is the similarities or the differences between the TCP/IP model and the OSI model, this is it. Application is the same as the first 3 layers here. Host to host is the same as the transport layer. Internet layer is network layer. Network access is the last 2 layers here. So as I've explained how it works, so also this conforms to the that also conforms to the TCP/IP model. Now these are protocols. These are protocols that work. So at the application layer, you have Telnet, FTP, you have HTTP, SNMP. These are protocols we might look later. Then at the host layer, host to host layer, transport layer is where you have the TCP/IP, which is for connection or reliable delivery. For UDP, which is connectionless or unreliable delivery. Then the internet layer, which is also the network layer, is where you have the IP, you have the ICMP for ping, the ARP, address resolution protocol, reverse address resolution protocol. The network access layer is where you have Ethernet, fast Ethernet, token ring, FDDI. So there's some of those things that might be complex for this stage, but it's very simple. So I will be looking at some of the protocols that are key. So remember, these are foundations. These are foundations. It is very simple. Foundations. Now, the first protocol we'll be considering here is what we call Telnet. 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 Now, this protocol is used for terminal emulation. This protocol is what allows network administrators to be able to manage network devices. So Telnet is what gives them that remote access into that device. So it allows a user on a remote client machine, which is called the Telnet client, to be able to access resources on another machine, which is the Telnet server. So Telnet allows a network administrator to be able to manage his or her network devices remotely. So, but the disadvantage of Telnet is that it is unencrypted, meaning that any information you send using Telnet protocol it is in plain text, it is in clear text, it is visible for anybody on the network. So that is Telnet. That is why they brought in SSH. So SSH is a secured version of Telnet. SSH means secure shell. It means secure shell. So SSH and Telnet are the same thing. They do terminal emulation. The only difference is that Telnet is unencrypted, SSH is encrypted. You have FTP also, file transfer protocol. This is a protocol that allows you to be able to download or transfer files. So whenever you upload files to your Google Drive, it is using FTP. Whenever you download files from your Google Drive or from any website, it is using FTP. So FTP is used for upload or download or for transferring files over a network, an IP network. So, and you have a secure version. So FTP is not secure, meaning that whatever it is that you transfer is unencrypted. It is clear text, it is plain, anybody can see it. But the SFTP means that it is encrypted. Whatever it is you send is encrypted. So somebody cannot see the information that you are downloading or you are uploading. That is what SFTP is. Now, there's also another protocol which is trivial file transfer protocol. Trivial, from the word trivial, means something little. So whenever you want to transfer a file that is very little, not big, they use the trivial file TFTP, file control transfer protocol. This protocol usually is used for sending configuration files to network devices or even network device operating system to the images. So, but it's used to transfer trivial files, files that are trivial, that are not that big, that are not that important. That is what the TFTP does. Another protocol we're considering here is the SMTP, which is a simple mail transfer protocol. The simple mail transfer protocol is what you use for email. Anytime you send or receive an email, it uses SMTP. SMTP is a protocol that allows for sending email or receiving email. So that is what SMTP means, simple mail transfer protocol. It has other variants like IMAP, Internet Message Access Protocol, POP3. So these are other variants of SMTP. These are other variants of SMTP, but it's used for email. Then another protocol we'll be looking at here is SIP. SIP is used for voice over IP. So whenever you make an internet call like Skype, Skype uses SIP. You use your WhatsApp call, video call, WhatsApp audio call uses SIP. SIP is what allows you to be able to make voice or video call over the internet. Whenever you're able to do any like Zoom, like this session that we're having now is using SIP, because SIP is a protocol that allows voice and video to be transported over an IP network. So SIP is what does that magic. When you can do video calls, you can do audio voice calls, you can stream over more like you can stream videos. So it uses SIP, and SIP also is a UDP protocol. And VoIP means voice over internet protocol. Another protocol also worthy of consideration is the SNMP, Simple Network Management Protocol. The protocol is used for managing devices. So in a network where you have devices spread across Nigeria or spread across Lagos, or even in your office, I want to have an understanding of the CPU, of the memory, of the temperature, of the traffic that is going through that device in real time. SNMP is that protocol that allows you to have such visibility. So SNMP protocol is very key. I've talked about the HTTP, the Hypertext Transfer Protocol, which is for web, the HTTPS, which is a secured version of the HTTP. So the difference between HTTP and HTTPS is that one is encrypted, HTTPS, one is unencrypted, HTTP. That's the difference. Now, another protocol we also consider and will be implementing, will be configuring in our hands-on lab is the dynamic host configuration protocol, the DHCP. DHCP. These things are very simple. DHCP is what does the magic that when you go to a network and you connect to a Wi-Fi and you're able to browse, remember, for anybody to communicate in a network, they must have an address. They must have an address. So what gives you or what assigns you an IP address automatically is DHCP. DHCP is what does the magic that when you come to a network, you plug in a LAN cable or you connect to a Wi-Fi and you're able to browse. DHCP is what does the magic. DHCP is what does the magic. So that's what DHCP. So it gives you information such as your IP address, your subnet mask, your domain in your default gateway. Okay, we've talked about what TCP is. TCP is for connection oriented, and it is to ensure that whatever information that you are sending is secure. And this is how it looks like. This is just the header. The header just talks about when the attaching port number, destination source port or destination port number and source port number into that information. This is what is tagged along. So you have sequence number. Sequence number is so that you'll be able to, once that information is broken down, you're able to track how many messages you sent. Acknowledgement number, because you need acknowledgement. There's also some other information here. We've also talked about the user datagram protocol, which is an unreliable protocol at the layer 4. And this is how it looks like. It's only source port number and destination. It has nothing like sequence, nothing like acknowledgement number. And we've talked about port numbers. And port numbers are like windows. So it's just like entrance in an airport. There are many, many entrances. So if you are departing, there's an entrance you must go to. If you are arrival, there's an entrance you must go to. So it's just more like windows or gates into a device. So there's a port, a window for email. Once that port is blocked, you cannot send or receive email because that window is blocked. There's a window for web. Once that port is blocked, you won't be able to browse. There's a window for DNS. Once that port is blocked, you won't be able to resolve URL to IP addresses. So that's simple as that. That's what port numbers are. So an example is Telnet uses port 23, SMTP uses port 25, HTTP uses port 80, FTP uses 2 ports, 20 and 21, DNS uses port 53, HTTPS 443. So these are port numbers that I use. So we also spoke, let me see. Okay, so
This conference will now be recorded.
okay, so we'll continue with protocols. So we're looking at all the protocols that are in the TCP/IP protocol suite. So we've looked at Telnet, we looked at FTP, SFTP, SMTP, HTTP, looked at some of the common or popular protocols. So another protocol which is, I think is the most common is the Internet Protocol, IP. That's where you get IP addressing. So actually, it's a protocol that works with at the network layer. So that's why you have IP address. So you always hear IP network, IP address, IP network. So it's more of a logical protocol that allows for addressing or the interconnection of devices. So IP looks at each of the packet's destination address, then used with the routing table. So as we go into routing, you'll be able to understand the the important work that IP plays in your information, in the transportation of your information from point A to point B. So routing is typically based on IP. So another, this is more like the header of how it looks like IP logically. So you have an area where source IP addresses are placed, destination IP addresses are placed, then data is placed here. You have some other information that are also attached to the header. Okay, so another protocol that is also important, very common, is what we call the Internet Control Message Protocol, the ICMP. Is what allows you to ping. Ping is a network utility that allows, or network tool that allows you to be able to test connectivity from one point to the other. So ICMP is a protocol that makes that magic happen, where you're able to check if from point A you can reach point B, and if point B can reach point A. So that's what a ping does. So it will send a request and it will expect a reply. So then you will now say there's connectivity. You have pinged the person. So an example is when you send a DM, a private message or direct message to someone on WhatsApp, you say you've pinged the person. Now you would know if the person has actually gotten your message, maybe by the WhatsApp signal, those two signs. It will show you that it has delivered. Then when you see a blue one, for those who don't have privacy enabled, you will know that the person has read your message. So that's more of a ping. So you have an idea that you have a connectivity, that you're able to send a message and the person got your message. So ARP is also another important protocol, address resolution protocol. If you remember when we were going through the OSI model, we talked about the network layer and the data link layer. So they are independent in many ways. So network layer has packets, is what we call packets, information packets. You have IP addressing. At the data link layer, you have frames. Frames is where you have MAC addresses. So address resolution protocol is what allows your MAC address to be mapped to an IP address, because those addresses are independent. So your system will have two addresses. It will have a MAC address and an IP address. So an ARP, address resolution protocol, is what maps everybody in the network. It maps their MAC address to the IP address, so that whenever you are sending information at layer 2, you'll be able to send it to the right person. So that is what ARP does. So we've looked at part A. So part A, which constituted, we're talking about the OSI reference model, the TCP/IP protocol suite, and we looked at each of the protocols that are in the TCP/IP protocol suite.
This conference will now be recorded.
IP routing. So let me give an example. Now, when you send a letter to someone, maybe someone in Canada, you don't know how to get to Canada. You might not even have idea of the type of the plane, the airline, or the airport that you land. You don't have all of those details, but you just send a message and you trust that the post office system in Nigeria, 9-Post, should be able to navigate or route your letter to Canada and deliver your message. So the same when you're using DHL, FedEx, UPS, you believe that they'll be able to have their way or navigate their way to just ensure that it's being delivered. Example is also when you order something online, maybe from Jumia. You order something online from Jumia or from Konga. Maybe you're in Lagos or outside Lagos. You just put your address there, and it is the job of Jumia to locate you, to ensure that that thing present at your doorstep. So whether it's a bus they use, whether it's a bike they use, whether it's an airplane they use, whatever means they want to use, what you are just concerned is that they deliver that message for you. So what happens is that when you send a message or when you make a request on the network, there are devices, just like the logistics firm, that are responsible to ensure that your information gets to its rightful destination. Their information that you send is being routed appropriately. So that is all the idea of, that's majorly the idea of IP routing, to ensure that your information or your messages or whatever it is you are sending is being routed appropriately so that it will get to the destination. So that is what IP routing is in simple sense. So routing basics, the IP routing is a process of moving packets from one network to another network. So I remember when I was talking about internet, the internetwork. So internet, it means internetwork. So there are multiple networks connected to each other. So routing or IP routing allows that you're able to send message from one network to another network. So there's a network in Australia, there's a network in Canada, there's a network in India. So routing is what allows that your information to leave the network in Lagos, to leave the network in Abuja, in Ibadan, wherever you are, to route it anywhere it has to route it so that it can get to that network in India or that network in US. So that is what routing is all about. You get, and it engages the use of logical network addresses such as IP addresses and hardware addresses such as MAC addresses. So routing basics. So just the way that before you can deliver a message, there are informations that you need. Somebody cannot just send a message without attaching a destination or a source information to it. Somebody cannot send you a message without telling you where you should go and without revealing his or her identity to you. So if somebody sends you, please help me buy something, the person will give you the message, maybe it's the money or a letter. It will give you the description or will tell you the address of the person or the people or the place you have to go. And when you get there, when they ask who sent you, you will be able to mention the person who sent you, who is the source. So in routing, you need some information before you can route. First, you need the destination address. You also need to learn about remote routers. So for Jumia to be able to send your message to somewhere in Lagos, they will ask maybe where's your closest bus stop, or they will make that findings. They might check Google Map. So Google Map will tell them the closest bus stop, the closest landmark, which you will need to pass through to be able to get there. An example is, let's say you want to go to US and there's no direct flight from Nigeria to the US. You have to enter interconnecting flights. It means that you will take a plane. You first of all, from your house, take maybe a bike or a vehicle or a Uber to the airport. You will go to the international airport and not the local airport. From that place, they will take, maybe if it is Kenya Airlines, they will go to Kenya first before they will go to maybe London. So there will be that interconnecting because there is no direct flight, because Nigeria or Lagos and US, they are not in the same continent, they are not close to each other. So they must go through different countries or go through different airports before you can get to your destination. So those are the neighboring networks that Nigeria Murtala Mohammed Airport or whichever airport you are going through will have an understanding of. So what are the possible routes to the remote network? So there are many ways to get to the US, to get to India, to get to Dubai. So whichever is the shortest route you will go with. So which one is the best route, and also how to maintain and verify. So you need to be sure that that airline or that plane you want to enter will take you to your destination. You need to be updated to know, are they still going to this area? Are they still going? You won't assume. So that is some of the routing basics that you need to have. So the router learns about the remote networks from neighboring routers, from the administrator, and it has what we call a routing table. Now, a routing table is like a map. Just the way you have a map of Nigeria. And it is believed that if you have the map of Nigeria, you should be able to navigate your way in Nigeria. Meaning that if I have the map of Nigeria and I'm in Lagos, I want to get to Abuja, it tells me that I can either go to Ogun State or go through another state that is close by. So from Ogun State, I can go to Oyo State or Osun State. So from that map, I have an idea of where I can navigate to because of the map I have. So in a router, you have a routing table, which is like a map that is able to help the router make intelligent decisions on where to forward traffic, on where to forward packets, on where to forward information. That is what a routing table is. Now, this routing table needs to be populated. It needs to be given constant, it needs to be updated because the road might be bad and it might be blocked, but you need to have verified information time to time that, okay, if I want to go to Ogun State, this road, it's just like we look at our Google map. If you're in Lagos or wherever you are and there's traffic, it tells you that this road is blocked and it will be able to map another path for you. Why? It's getting updates. It's getting updates on, okay, this is the shortest route, just the way Google Map does. Now, also for routers, there's what we call dynamic routing and static routing. Static routing is that you're the one giving the router updates on where to navigate traffic or navigate information to. Why dynamic means is getting it from different sources, from other protocols, from other routers. So it's able to intelligently predict that a road is free, a road is not free. Example is in Lagos here, between static and dynamic routing. In Lagos, for instance, if you want to get traffic updates, there are two ways. You either go to Google Map or you listen to traffic radio. Traffic radio, people will give you updates that this road is blocked, this road is available. Now, these are people who are manually giving updates. But in Google Map, Google uses a lot of terrestrial and a lot of analytics to be able to tell you the road that is free and the road that is busy. So that is an example of dynamic routing. So I've explained what dynamic routing is, and what allows or gives that update is what we call a protocol. So static routing, dynamic routing. And I've explained what static routing is. You manually give updates, you manually configure on the router how and where it should route packets, route information. Dynamic routing, it gets updates from its fellow routers, it gets updates from protocols. So dynamic routing is divided into two. So you have the interior gateway protocol and the exterior gateway protocol. Now, the interior gateway protocol is within what we call an autonomous system, within a network. So an example is just the way we have intranational and international. In Nigeria, we have international flights and we have local flights. So the protocol that controls local flights is called interior gateway protocol. The protocol that controls international flights is called exterior gateway protocol. So whenever you are communicating within an autonomous system, within a network that has been categorized as one autonomous system, as one entity, then you use interior gateway protocol. But when you are communicating with an external network, which is in a separate autonomous system, you use an exterior gateway protocol. Example of an exterior gateway protocol is BGP, Border Gateway Protocol, BGP. So interior gateway protocol, which is within an autonomous system. Remember, it is like the local flights. in a country that is just within that country. They don't go beyond the borders of that country. It is always within the country. So you have examples, you have two classifications of, you have three actually, you get, of interior gateway protocol. You have what we call distance vector, link state, and hybrid. But for here, we just talk about the distance vector and the link state. We have distance vector and we have link state. Now, the distance vector protocol includes RIP RIP version 1 and version 2, and IGRP, Interior Gateway Routing Protocol. These are examples of distance vector protocol. The link state protocol example is OSPF, Open Short Path First. That's what OSPF is, Open Short Path First. We also have ISIS, Intermediate System. That is ISIS. Now, let me explain. You have distance vector and you have link state. Remember how I explained that there are protocols that give updates as to routing information. Now, for distance vector, is parameter for the best route or is criteria for the best route or shortest path is distance. It's just like saying that no matter how tight a road is, as long as it's the shortest cut, I will follow it. That is what distance vector is. It's saying how many bus stops will it take me to get to my destination. It doesn't care if that road is tiny, if that road is big. What it just looks at is how many bus stops to my destination. So if I would just go to 2 bus stops to my destination and I spend 10 hours on the road, I don't mind. It is just 2 bus stops. So what is criteria for distance vector protocol is the number of bus stops, the number of routers, the number of hops to the destination. While for link state, it doesn't care the distance. It just looks at how wide the road is, how big the link is. So it doesn't care, even if it is going to be 2 kilometers, as long as the road is wide enough, I will go through it. As long as there's no congestion on that road, I will go with it. That is what link state. So link state protocols are key on the link. How big, how free, how large is the link? Distance vector are key on how many bus stops, how many routers, how many hops will it take me to my destination. I hope you understand.
Yes.
Yeah, okay. So now, so there's also a special breed of protocol that comprises of distance vector and link states. That is what we call hybrid protocol. And an example is EIGRP, Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol, EIGRP. So we call it an hybrid protocol because it also works by distance vector and works by link state. That's why it's called hybrid. So it takes characteristics for distance, it looks at distance and also looks at link state to be able to make decision as to the shortest path. So that is hybrid. So
This
okay.
conference will now be recorded.
Okay, so we will be looking at our hands-on lab, our hands-on architecture. So we'll be installing the tools that we need to build this network. So Ednos Bank has contracted a network, has consulted with us, and they want us to build a network for them. And they have a branch in Abuja, they have another branch in Port Harcourt, and they have a branch in Lagos, which is their headquarters. Also in their branch in Lagos, they have a server farm where you have an Active Directory, you have a web server, a file server, and people in Abuja or staffs in Abuja are able to connect to the web server for information. Staffs in Port Harcourt are able to connect to the headquarters in Lagos for information. So like their banking application, core banking application, they're able to access it. All the customer details of this bank are residents in Lagos. So it's expected that the branches should be able to process transactions even from their remote locations. So the tool we'll be using here to build this network is Cisco Packet Tracer. We'll be using the Cisco Packet Tracer, and I've sent to you, I send part of the access to the Mega Drive is this particular tool. So I'll be installing it right now. So I'll accept. So I'm installing the Cisco Packet Tracer, and it's 32 bits. 32 bits can work on both 64 bits and 32 bits. So I'm installing Cisco Packet Tracer. Just install. So we'll be using this for our network simulation. I'll also be installing VirtualBox. VirtualBox is what we'll be using for our system administration. We'll be running Windows, be installing Windows on it, installing Ubuntu, which is a Linux variant. I'll be seeing how it works. So I'll be installing VirtualBox. So these are the two tools we'll be using for our hands-on lab: Cisco Packet Tracer and Oracle VirtualBox. Finish. Okay, so it should work on yours. I'll check why it didn't come up on mine for the Oracle. So, but let's bring up the really like multi-user when you go. So it's coming up. So this is how it looks like. For some of you, if it's asking for this, you can continue as guests, or you sign up. When you sign up with NetAcad, you can get this for free. It's free. So, but I'll just use as guest. I already have a NetAcad Network Academy credential, so I can sign in. But for here, I'll just be continuing as guest. Okay, so this guest login. It will take some time before it disappears. Okay, so but you could.
Please, sir, I want to ask a question.
Okay.
Okay, apart from the virtual box, can we use VMware?
Yes, you can.
Okay, will it still be the same configuration, or
No,
it
so
will be
but
quite different?
it will be quite different. But as long as you can run your operating system on it, is not a problem. So the reason why we are going for VirtualBox is two reasons. One, VirtualBox is lighter. For some of your systems, it might not be, your system might be limited in resource. Two, VirtualBox is free, is open source, meaning you don't need a license for it to work. But for VMware Workstation, you need to have a license for it to work. So that's just the two major reasons why we're using VirtualBox. But VMware Workstation is more robust than the Oracle VirtualBox. Okay, so I don't know if I've answered your question.
Yes, sir. Thank you very much, sir.
So I'll walk you through the Cisco Packet Tracer. I'll just give you a brief understanding of what it is. So Cisco Packet Tracer is a simulation tool. A simulation is like a lab where you can build and you can break without having to incur costs, in the sense that you could build a network, you could design as much as you can, it's an experimental floor, experimental environment. So the Cisco Packet Tracer has this environment where you can design a network, you can configure the network, and you can try it out as though to see how it will work in production in real life. So here you have a tab where you can save your files, you can edit, you can do some preferences, you can zoom, you can do some other tools like tools, extensions. So these are some of the tools, just like your Word document that you have some tabs like your menu bar. So, but our major interest is here, down here, where you see network devices. So I would want to zoom, I want to zoom this so that you all can see. So as you can see, as I've come here, network devices, it shows me model of network devices are here. You can see how many there are. So you have a 4331, 4331 for routers. These are routers. 1941 model, 2909 model, 2911. These are all models of routers. When I come to switch, I need to restart my system. So, but when we come to switch, okay, let me, if it's the magnifier, so apparently it's the magnifier that is making it to misbehave. So, but I need you to confirm that you can see, even though it's small. Can you see what I'm doing? Hello?
Yes, sir. Yes, sir.
So when you come to switch here, you can see series of switch, 29 series switch, PT, different types of switch here. When you come to hub, so hub is not generally, it's just as I explained in the first class, it's outdated, it's obsolete. Then wireless device is where you have wireless devices here. This is for firewall, Cisco firewalls. When you come to end devices here, you see PC, see laptop, server, and printer. These ones are motherboard for network devices. You see network connections, you see automatically, you see console cable, see copper straight through cable, crossover cable, fiber cable, phone cables, coaxial cable, and some other types of cable. Even ESP is here. This is for structural cabling, but we won't be using structural cabling here. So this is really the environment we'll be playing around with. You get. So based on our architecture, so let's put pen to paper. So we have 3 routers. Yeah, so well, the routers, I'll be using a 2911 router. So I need 3 of them. I need 3 routers. I'm working by this topology. So I have switches. I have 2 switches in the headquarters and one switches at the branches. Okay, so let me get to switch. I can use a 2960 switch. So 2 switches in Lagos, 1 switch in Abuja, 1 switch in Port Harcourt. Okay, so what are the other devices I need? So I have a laptop, a desktop, a wireless access point, and a printer. So there's a laptop, there's a desktop PC, there's a printer, and there's also a wireless device. So if I come to network devices, this wireless device. So which would I use? Okay, let me carry this 3509, not 2909. Let me even see. This is a wireless controller. It will serve for we. So once I highlight and I click delete, or I can highlight and click delete. This one is a much more later edition than the one I had before. So I can go to select here. This delete if I want to delete. This resize. This place note. This draw line. Draw a rectangle. Draw an ellipse. Draw preform. Add simple PDU. So if I do delete, like anything I click, it will delete. So that's just it. So I need a wireless. These are wireless controllers. I need a wireless access point. Okay, so let me take this one and see. So this is a light wireless access point. Yeah. Okay. Said it must be power on. So if I zoom in to find the power, okay, this is the power. Okay. Okay, we'll come back to this. So, but these are access points. So for the laptop, we need a desktop also in Abuja, a laptop in Abuja. Okay, a server, don't need server now. We need a printer, we need an access point. So I could just pick the access points once and for all and place them. Let me even see this one. Maybe this one will suit us better. Okay, just to plug it into common. Okay, so that's just by the way. So we'll deleting it. So we'll come and use this 37. We need a wireless access point here. We also need a wireless access point here. We need a desktop. We need a laptop. We need a printer. Okay, so I've put in all the things that we need at each of the branches. What I've not put now is the servers. I need 3 servers. So I come here, 3 servers, 1, 2, 3. So one is AD. I can label it here. I can call it AD. Now I can label it here. This is web server. Label it here too. File server. Okay, so I can label this Lagos HQ. That's the router. I can label this Abuja. Label this Port Harcourt. Okay, we're making progress. So now we'll now do our connection. So remember when we were talking about network connections and we talked about we using straight through for different devices. So we'll connect our router to our switch, connect our server to our switch. So I want to reserve the first port on the switch for the router. So switch first usable port to switch. So I'm attaching it to G0/0. Okay. I'm going to do the same here. My PC to the switch. Laptop I'm using wireless. My access points to my switch. My printer to my switch. I'll do the same here. Router to my switch. To my printer. To my access points. So I've done for Port Harcourt, I'll do for this thing, Abuja. Printer. Wireless access point. PC. Okay, so we're making progress. So if I want to add some beauty to it, so I can come here, I came to this point, I click this palette dialog and I choose ellipse. So I can select a color. What color will I want? Okay, I want a green. So fill color. So I'm using green for this thing for Abuja. Can look for another color for Port Harcourt. I'm using purple for Port Harcourt. Okay, so the LAN in HQ. What can I use? Okay, let me use orange. I'm using orange. So for the server farm, what do I use? Okay, let me use blue, light blue. Okay. So I go back to select. So these are the beauty of the color is just for you to be able to logically separate them so that you know where you're connecting to. Okay, so I forgot to connect the switch to the router. Does anyone have question up to where we are now?
No questions, sir. Continue.
Okay, sir.
So
Hello?
yeah,
Hello, sir.
I'm with you.
Okay. I I want to inquire why those type of cable and why those specific ports. Why not just some other ports? And why those type of cable and the cable you are using, sir?
Okay. So in the module one, we talked about different ports and their usage. So we said
Yes.
straight through is used for dissimilar devices that are different. A
Yes.
server to
Yes.
a switch, a router, different devices. You use a
Yes,
straight
sir.
through cable. So that's why we're using straight through. For the switch, you can use any port on the switch. You get, but
Okay.
usually people just like using either the first port for as the gateway or the last port as the gateway. For
Okay.
some that has what we call SFP, we'll look at what SFP now is. They might use this because it's a larger bandwidth. Because one thing, your exit, you want, it's just like in a hall. The exit is usually the biggest door in that hall, whether it's a
Yes, sir.
church, in a mosque. The exit where plenty people are coming in or going out, they usually make it a bigger one so that you won't have enough traffic. If you make other doors smaller, bigger, you make the exits smaller. To be hard for people to leave that premises. You get, so usually the one connecting to the router is usually the one with much bandwidth. So if it is in a switch that has fast Ethernet, you might use the fast Ethernet for devices, then the Giga Ethernet as an exit interface, which you will connect to your router or connect to your device for as exit out of the network. I don't know if you get me.
Yes, sir.
Okay.
Not really, not really,
So,
sir.
okay, not really. I think you just joined that day when you asked the question. So what he was asking was that why is it that there are specific ports on the switch that you
I
use?
don't understand.
So the question is asking is why is it that you choose some ports on the switch and not just random ports? Do you understand the question? Hello? Hello?
Hello, support. My network is, sir.
Do you understand the
My
question?
net, sir. No, I
Do you
don't understand the
understand the
question. I don't understand.
It's asking that why are we specific as to the port on the switch that we want to use rather than using any random switch, any random port.
Okay. Why, sir?
You get, so I was explaining that the reason why most times people like using that is that the port with the largest bandwidth. So for instance, this kind of switch, it might have fast Ethernet as 1 to 24. Then these ones here are bigger Ethernet. You want to use the port with the bigger port as a exit. So the one connecting to the router, you want to use the exits, the one with the bigger bandwidth. I don't know if you get me.
I understand, sir. I understand.
So that's why I was now using whether a church, a mosque, or a big hall, that the exit door or gate used to be big so that plenty people can go. Because if it's a small door, you have enough traffic, it will be a bottleneck when everybody wants to go out. So that was what I was explaining. And you can start to choosing 1, 2, 3, 4, 5, 6, 7, 8, and just rather than randomly, just to make it neat. So that's the explanation I made to Ayanfe. Okay, so now we've been able to establish or physically connect Lagos, Abuja, and Port Harcourt. Now, our this thing will be, how do we connect Lagos to Abuja? How do we connect Port Harcourt to Lagos? Note, remember the limitation on your UTP cable. It cannot go beyond 100 meters. And you know that Lagos to Abuja is not 100 meters. Port Harcourt to Lagos is not 100 meters, it's kilometers and thousands of kilometers. So what we'll use in this regards is fiber, because fiber can run kilometer, it can run thousands or even millions of kilometers. It works at the speed of light. Fiber. So we'll be using fiber to connect Lagos to Abuja, Lagos to Port Harcourt. So how do we do that? Now, if you check this device, this is our router. If we check our router, let me zoom in. You see some empty port expansion slots. For some of you that have desktop at home, you will see some places that what they call expansion slot, where you can add card to it. Or if you have, what do I use as an example now? So like a room divider in your house, there will be some slots where you can add other things. You get. So also devices, they have the idea of scalability, meaning that you might need that device to do more than what you are using it to do now. So they will give you space where you can put expansion slots. So this device has many expansion slots here. So you can see many of them here. So we'll go to a marketplace here and look for a slot that will help us connect fiber. As you can see, this guy does not have fiber. It's Ethernet. It does not have fiber on it. But we need fiber for we to connect Lagos to Abuja, Lagos to Port Harcourt. So what we'll do, we'll off our router first. Remember, most devices, you don't tamper with it unless you off it, because it's just like your system. You can't remove the RAM while it is on. If not, it will damage the RAM or the motherboard. So we'll come here. Here it tells us our variant. So there's this SFP, 1 giga Ethernet SFP. You can see here, these are different types of connectors. These are switch ports. This is a different type of connector. Then this one is just cover. If I want to cover it, then you see another one. So this is an SFP. So first of all, I would attach this. I'll drag it here and place it here. So I have placed this here. Because I need 2 fiber ports, I will also attach on the second port. So these ports are SFP ports. Now, let me Google SFP for you to see it in real life. This is how SFPs are. You can see them. There will be a hole inside the switch or inside the device like this. Then you will now put this very thing inside. So there are 2 types of SFP. There's copper SFP. Copper SFP is your Ethernet. This is a copper SFP. Then you have a fiber SFP. It has this fiber. This is how it looks like. So you can see this is an SFP and this is fiber cable. I don't know if you're with me. So this is an SFP and this is a fiber cable. So what I have done now is that in our device here, we've put in an expansion slot that can accommodate SFP. It has a hole. The next thing to do is to attach an SFP. So I got this one from here. So it's a single mode wig for one small form factor pluggable. That is SFP slot. So if I come here, this is an SFP, fiber SFP. Look at it. 1000 base LX SFP operates as Giga Ethernet ports. So I'll carry it and put it inside here. Can you see? I'll carry it and put it inside here. So I have attached an SFP to this expansion slot. I've also attached another SFP to this expansion slot. Having done this, I will now on my device. My device is on. So my device is on. It means this guy has 2 SFP ports. I will do the same here because I need 1 fiber SFP. So if you didn't get it the first time, you get it now. So I'll first of all off my device. Let me zoom in. I'll first of all off my device. Then I'll come here, add an expansion slot for SFP. Then I'll come to this last one, which is the SFP. Then drag it again, attach the SFP. I've done that for Abuja. I will on my device again. I go to Port Harcourt. I'll do the same thing. Okay, so I'll need to turn off my device. I need an expansion slot. This is the expansion slot I'm using. I attach it. I need an SFP. I'll use this as my SFP and I'll plug it. Okay, so having done that, I can now power my device. So I'm done with that. So I have an SFP port here, I have an SFP port here, I have an SFP port here. So if you notice, formerly we had only 3 ports, but we added 2 more. So this is the implication. So if I come here and I look for a fiber, this is a fiber cable. You can see a fiber. I bring it here, I plug it. It's showing me the fiber cables. This is one fiber, this is another fiber. I take one fiber, I go to Abuja. It's showing me one fiber because it was only one fiber I did. I've attached one fiber here. I come here. It's showing me one fiber that is free. I plug it. I connect it to the next fiber here. So what I have done here, I have done the physical topology of my setup of my hands-on lab. So next week we'll be continuing with the configuration.
This conference will now be recorded.
Hello,
I
sir.
think we'll be working on this tomorrow.
Hello.